Rich Cangemi, Mangrove Construction. We're back here at our Redington Beach project. We're going to talk today about our Hambro floor system. That's a solid poured concrete floor system with a metal joist that's integrated into the floor. Derek, if we take a look at this plan here, we're going to see some notes that we left for the finishing crew. This is basically everything over the garage here. So we've got a couple of spots where the folks have to put a pour stop in. You can see we left them some notes based on the varying depths. We've got 3-inch, 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 4 3/4. If you can see that note, 4 3/4. Step down to 3 1/4 in the back. And part of what's going on here is balcony areas by the code requires them to be engineered for a greater capacity. So the system needs to be just a little bit thicker in the concrete to accommodate the fact that there are double layers of steel in this section here. So that's the system. If we pan down here, you can kind of see an overview of what's going on here. You've got the metal reinforcement. That's a heavy-duty mesh. It's not a normal type of a mesh that you might see that's poured in a slab on grade. And then these integrated joists, and we'll actually get a look at this. Roll bars are here just to temporarily support the plywood while the pour happens. So if we kind of take a look at one of these joists right here, you can pan up and see what that system looks like. And essentially what happens is the concrete pours and envelopes that integrated joist, and that creates the strength. It's a very efficient system, uses minimal amount of resources for the amount of the structure that and strength that we get. So very green technology. 3 inches of concrete as opposed to 4, 6, or 8. We had a couple of choices. We could have went with a system that was precast and basically craned in place, and that would be 6 or 8 inches of concrete, and then a 2-inch deck on top of that. So in this case, we're going to end up with just 3 inches of concrete. This is actually more affordable than that system and is going to be just as strong. So really neat technology. A couple of things you have to watch. Bracing requirements are key with this system. So you can see we've got both bracing every couple of feet to hold the plywood. And this plywood can be reused, by the way. So we'll go ahead and use this on another floor system. So really economical and earth-friendly technology. Okay. So this is that Hambro truss we were talking about. It's a metal truss. You know, there's a reinforced web. It's a nice system because it gives us room to get, electrical through the floor, plumbing where necessary, and it has this integrated flange. And this is really kind of neat because what happens is the concrete pours inside this flange, and that creates that strength. That this system here, the flange extends all the way through the concrete. Moves the loads through the truss and grips, and it uses much less steel with a system like this. So this isn't a new technology. This is a proven technology. It's been used in commercial for many years. It's used in residential and construction projects like this. We like it. As we talked about before, it's a very efficient use of materials, and it's affordable, and it creates a great system. Floor is very stiff, and it's great if you're going to tile above it because you can attach the tile directly to the floor system because it's a concrete deck without having to mud set in many cases. So this can be much more cost effective in those situations. And what happens with this is you'll see that mesh is kind of draped between it, and that creates the strength. It all ties together as one system. One of the things you'll notice is that we've got a transition of heights here. So this girder truss here actually has a wall on top of it. You can see this one is a little bit heavier than the rest, this balcony area. But also, you're going to see that this is pitched. And as we go up top, we'll really be able to see that transition of the height. So we're going to come from the residence, which is at one elevation, and then we're going to step down onto the exterior balcony, and we accommodate that through the way that we've set these trusses. We'll be able to see that in just a minute. Some of the things that we're looking for in a system like this is we want to make sure it's properly braced, so it's safe during the pour. We want to make sure that all the steel is in the right place. So we've got to be certain that every single one of these girders is placed exactly where it is on plan, because in a lot of cases on a plan like this, you're going to see that the alignment may be placed by the engineer to support a particular load that's coming from the floor above. And so it's very critical. So we're going to double check all of these locations prior to the pour, and we'll have a second person check these locations. And we're going to be very critical in the way that we do that so that the tolerances are within a quarter of an inch or so. And I'll give you an example of what I mean by that. So you come around here, you can see all the spacing is pretty straightforward. You'll see that area over there, you can see it really, it's really pronounced over here in this section. There, you can grab a picture of that. You can see how that steps down in that section over there. So this is where the floor transitions. So we really want to be certain that we get that transition in the right spot, right? Because the doors above are going to line up on that. Sliders going to line up right in this section. So we want to be in the right place for those sliders. Okay, so we're up on top of the deck here, and we can kind of take a look at the view here. So we've got the upper section of the joists, which are exposed, and your mesh that drapes between it. So this is a heavy-duty mesh system. We've gone through, we've done the inspection. Inspector was just out here. He's basically passed, so we're ready to pour here. Weather's not looking so great here. This morning we had planned to have concrete trucks out here, but we called them off. We do not want to be rained on this type of a pour, so we're going to look for doing this pour tomorrow. Better to be safe than sorry. And you can see most of the system will have just one layer of mesh. It's supposed to drape between these trusses. That's what it's designed for. You want to have overlaps of at least 2.5 squares, so we've got that in all cases, and it's very critical that we get this to run out onto the wall system. And you can see that pretty well over here. You can see how the joists are set. They're set with these shoes. We want to get at least 3.5 inches of bearing on each one of these, and more if we can. It's a full 4-inch shoe, so it's important. That's what we talked about earlier. You know, if the walls are off just a little bit, that can create that difficulty where you don't have all that bearing surface for a truss system like this. Again, we didn't have any of those difficulties here because the layout was really you know, spot on, so that worked out well for us. We've got all of this extra mesh, okay? The code requires that extra mesh because balconies are considered a gathering space. So the live loads are much different than a living space. So that extra mesh will allow this to support those additional loads. In addition to that, we've got that extra 1/4 inch of concrete. So concrete and steel, when they're put together, there are requirements to meet the engineering that's needed for the balance between the two. So it's important that you follow those instructions that come from the engineers. In this particular case, the engineering that was done for this floor system is done by the manufacturer. So they're experts in it, and we pretty much follow their instructions to the T. A couple other things. You can see all this rebar. This is for the in preparation of the floor system that's going to go above it. So we've got all of these uprights in the proper locations to support that insulated concrete form system that's going to happen here next. There's lots of uprights. This is a beach residence, and we want it to be strong. It should support, you know, possibly in upwards of 200-mile-per-hour winds based on the engineering that's done here. The code requires us to build to 150 miles an hour in this area, but this type of a system is just going to be stronger based on the way it's designed. So these are going to run up about every 16 inches on center, and then there's horizontal reinforcement that runs 16 inches on center. Creates a very strong system, and when it's all tied together with a concrete deck like this, you've got, you know, we've got a bomb shelter. It's about the best way I can describe it.